Okay, we're back and we're here again with Mark Kapner, that energy guy. And as we showed you the bill before, he's written some things here on the board to explain to us a little more in detail of what these things on a typical bill may mean. Okay, go ahead.
Okay, thank you very much. I'm going to explain how your monthly bill is constructed, and this applies to commercial buildings. It applies to not-for-profit buildings. It's basically everything other than houses. Houses have a different way of constructing the bill. So we've already seen the bill has about a dozen or so separate lines, and it's really not very complicated if you understand how it's constructed. So here we go. Number one, the electric bill every month is really the sum of two products. Product is one number multiplied times another. So the formula for the bill is pretty simple. These are the two numbers that sum together. One is the product of a price expressed in cents per kWh. kWh stands for kilowatt hours, and that's the way we measure the quantity of electricity consumed. So that number, that cents per kilowatt hour, is multiplied times the kilowatt hours that your electric meter shows you've used for the month. The second term is the product of a number which is called the demand charge, but it's a dollars per kilowatt peak. Now, I'm going to explain shortly what a kilowatt peak means, but for the time being, trust me that this second term is the product of a dollars per kilowatt peak, that is called a demand charge, and your measured peak kilowatts, kW small p, peak kilowatt demand. So we'll explain how that peak kilowatts measured. Just right now, it's important to understand there's really two things that the utility company is measuring every month. One is your kilowatt hours consumption, and the other is your kilowatt peak. So it seems a little bit more complicated than this because each of these two prices, the cents per kilowatt hour and the dollars per kilowatt peak, are actually presented on your bill as separate line items. And this is what they are. Cents per kilowatt hour is very simply the sum of two numbers you'll see on your bill. One is the energy charge, it's called energy charge, and the other one is the power supply adjustment. Both of them are shown on the bill, and each of them is shown as a cents per kilowatt hour. And very simply, you just add together those 2 cents per kilowatt hour, and you come up with the number, which is shown up here as cents per kilowatt hour. For Austin Energy, right now, for this particular customer, those two numbers sum together to be right around 6 cents a kilowatt hour. Now, the second term is called the demand portion of the bill. And again, the utility is measuring your kW peak, which we'll explain in a few minutes. Now we've got three terms, 3 lines on the bill, which really add together. All of them are expressed in dollars per kilowatt, shown here, and it's really the sum of 3 different terms. One is called your electric delivery, the second is called the demand, and the third is called regulatory. So those 3 numbers add together. They add together to a number right now of $14.84 per kilowatt peak. That number goes down in the winter. It goes down to $11 and change. So this is seasonally adjusted. This is not. So very simply, that's how your bill is constructed. Now, with solar power on your building, you're going to do something very important. You're going to reduce the kilowatt hours that get multiplied times that price. But the way the utility does it is they basically show you a line on your electric bill, which is the measured kilowatt hours produced by the solar system. Of course, that's metered separately from your main meter. They then multiply that times the sum of two numbers. One is the value of solar price, and I'll just show you those right there. The value of solar energy is equal to kilowatt hours produced by the solar and that's multiplied times, right now the price that's multiplied times is, for commercial at churches, 11.7 cents per kilowatt hour. And that number, product of the kilowatt hours of solar and the 11.7 cents, that's shown on your electric bill as a credit. So the utility will calculate your bill reflecting your total kilowatt hour consumption, some of which is coming from solar, some of which is coming from the utility, but they basically measure the total kilowatt hour consumption of the building, and they construct your electric bill. Then they do a computation of the solar energy produced, multiplied times 11.7 cents, and that is a solar credit shown on your electric bill and subtracted from your bill. In the event that that credit equals or exceeds your bill, they will carry the extra credit, the unused credit, to the next month. So you get full value for the solar energy produced. And that's as simple as it is. Now, a little bit more complicated. Let's look at batteries. Batteries can be added, energy storage system can be added to any building with or without solar. So they're really, the two, battery storage and solar, are really independent to a certain extent, in that you don't need to have a solar system in order to see a battery go in place and save money. How does a battery save you money? Very simply, the battery will reduce this kilowatt hour peak. As long as you're discharging the battery and the juice goes back into the building, you discharge the battery at the time of the peak, you will reduce the peak demand. You'll reduce that number, so you're going to reduce that term, and for every kilowatt that you reduce the load for a given month in the summer, you're going to save $14.84. That's how batteries save you money. They reduce the kilowatt peak. They actually don't do much at all to change the kilowatt hours. If anything, they will increase it slightly, but the savings due to reducing the kilowatt peak greatly exceed the additional cost that you incur through charging the battery. And when we show the graph of a typical electric usage profile, then we'll show you exactly how batteries work in a building.
Okay, thank you so much. We are talking again to Mark Kapner, that energy guy and founder of Kapner Solar Energy and the Kapner Solar Initiative. What he's describing is how we can use solar panels on churches and synagogues and save on an energy bill. And he's given us a few details on a bill to illustrate for us how that works. When we come back, Mark, that energy guy, is going to discuss in more details how we can save energy using solar panels and solar batteries. Please subscribe to the channel, Kapner Solar Energy on YouTube, and we will see you again.